Hi everybody, round two of our review session for the final. This deals with chapter 10 and 11. Sorry if the sound doesn't sound as crisp as it did yesterday. I forgot my ShamWow headphones today, so at home. But anyway, I'm going to start with circle stuff. This was from chapter 10, circle, area, and circumference. Then we go to chapter 11 stuff later in the movie that deals with the volume issues. All right, so the first two concepts are kind of intertwined. Circumference, all right, again, circumference is a kind of a grade school concept you had quite a long time ago, and there are two formulas for it. By the way, we do have a formula sheet for the final, mentioned it in class, but it's what the Park exam gives. The only reason I bring it up is circumference is on there, but it's not labeled, so you'll have to know. If we give you or we are going to give you the formula sheet, you'll know when to use it or know when to use it. But this one is not over here, so you might want to pay attention and understand how it's related to circumference, and then through figuring stuff out, you'll do just fine. You really should. So what is circumference? It's like the distance you would take to walk around this circular, let's pretend it's a track or something, not that those exist, but so it'd be that linear distance. One of two formulas. I drew a diameter, and of course we all know a diameter is made up by two radii. So that's why these two both work, just so you know. So let's go to arc. Now pay attention to this word, length. Length is not arc measure. Arc measure is in degrees. A full circle, arc measure would be 360, because this central angle all the way around would be 360. Everyone knows that. But arc length is the distance it would take to walk from maybe just here to here. And all you see in this formula, I picked this one is arc length is just a portion of circumference. So there's circumference. Then we got a fraction next to it. So you have to just think a little bit fractionally. Now I didn't want to confuse you with a different symbol there. I just put an angle symbol in the middle there. This is a central angle. What we're identifying is a central angle is equal to the arc length it intercepts. We talked about that yesterday. So I don't care which one's given. It doesn't matter. Either of these represent what fraction of the circle you're dealing with. So let's say this was 60 degrees in here. Well, then I put 60 over 360, which is 1/6. So you'd basically have 1/6 of the circumference. Now, so it's time to go to the worksheet where I do one, you do one. And then hopefully just by practice it sinks in. All right, so this one flat out says find the circumference. That's a full circumference. That is, how long does it take for me to walk, or what's the distance that I walk from here to here? All right, so circumference is, I'll get back to you in a minute. So circumference equals 2 pi r, so 2 pi times 8. So that is 16 pi. And then we label that as miles because that's how far we would walk. So what would 16 pi be on your calculator? Already typed it. Now again, if you rounded this to the 10th, it would be 50.3 because that's the 10th position. Hundredth. It would be 50.27 because the 5 knocks it, so on and so on and so forth. So 50.3 miles would be the approximate. Now it didn't say to do that up there, but I'm just kind of practicing both so that you're aware of that when it gets to the final in 2 weeks or a week and a half. This is the exact answer. That just means you leave pi alone as like it's a symbol, even though we all know it's approximately 3.14. And then this is the approximate answer. All right, let's move on to this one. And you can see I do, you do. So I did 1, you do 2. I do 3, you do 4. All right, so the measure of arc CD, that's from here to here. The measure in degrees is 45 degrees. All right, but what is the arc length? So all that 45 establishes is I have 45 out of 360 in arc measure, or 45 degrees here out of 360, which would be a full circle. So, it's not really circumference, sorry. Use the wrong letter there. So arc length equals, and you're probably ahead of me, I hope you are, circumference, which is 2 pi r, radius is 18, given flat out, times what fraction of the circumference are you dealing with? 45 out of 360. What else we can do to get that figured out? But 45 over 360 is 1/8, I believe, doing my mental math. And then 2 times 18 is 36 pi. Now, a bit of a pain for writing this in exact form, because what happens is this is 36 over 1, so it's 36 over 8 times a big fat pi if you want to make it that way, or put it up with 36. It don't matter. But what they have in common is 4. So 4 times 9 is 36. 4 goes into 8 twice, just simply reducing a fraction. Now again, this is arc length. So it's 9/2 pi centimeters. All right, so that means if you were an ant, well, actually, let's get the approximate. 9/2 is 4.5. Type it on your calculator. Times pi. Boom. 14.1 would be the approximate, 14.1 centimeters. And we could get a measuring a ruler, that's what it's called, a ruler, and see what 14.1 centimeters are. That's how far that would be from there to there. So it's a straight line distance, even though it's curved. That's what it means. That's why we label it centimeters. Next two concepts grouped together is area. I don't have to give you a big spiel about area, but that's the space inside of a circle. All right, and then this formula is on your formula sheet for the final because it's on the Park exam formula sheet, and that's what we're, that's what we live our lives by right now in the math department. So C equals pi r squared is area. That's often what students confuse between the two. There's a 2, a pi, and an r in it. All right. The only thing I could say is area is units squared. So r squared. That might be a good way to remember it. I'm sure your teacher has given you plenty of ways to remember that. So that's enough of that. So that would be the space inside. So what's area of a sector? Same spiel. Not spending a lot of time on this because whatever this angle is or whatever this arc measure is, it tells you what portion of the circle you're dealing with. So area of a sector is the space inside this piece of pie, right? Or just this little thing right here, this part of the circle. So again, area of a sector, just gonna be lazy with the little symbolism there, equals area of a circle again, but times what fraction you're dealing with. So let's say that was 60 degrees right here. Now, no, I'm not doing that. This is for notes purposes. This is called some angle. Whatever angle measure it is or whatever this arc measure is, the measure of that angle, which is the central angle, divided by 360 times pi r squared tells you what portion. So, many different symbolisms used for the top, but that has to be the central angle or the arc measure that would be equal to that central angle, whatever it may be. So again, if that's 60 degrees, 60 divided by 360 is 1/6. I feel like I'm over-explaining it, but I just remember that we did have issues with this stuff. So, all right, real quick on this. Yowza! I forgot to do that one. We'll have to go back to that. Apologize. And that one, yikes, out of order. So we'll go back to those as maybe a some questions that we can deal with. I'll do that at the end of the video. So hold off on those numbers. All right, so area, real quick. Area of this situation is just C equals 12 squared pi. I'm sure many of us don't need this. This is pretty standard. We've done it before. That is inches squared because this is area. And then you know how to get the approximate. You just take 144 times 3.14 or times pi and get the decimal. Think I'm overdoing it, so let's just move on. Find the area of each sector. Okay, so I want the space inside this piece of pie. So 40 degrees tells me this arc measure is 40 degrees. Central angle equals the arc it cuts. So this is 40 out of 360 is what I'm dealing with. Times radius squared times pi. Might get a little ugly, maybe not. Let's take a look. And again, I'm just going to do this offline. You got calculators, you know how to get these answers in nice format. So offline, I'm going to do that. Actually, it was a lot easier than I thought. I forgot 9 times 40 is 360. 360 times 360 is 1. This ends up being 1 pi, sorry for my ugly pi there, centimeters squared, which would approximately be 3.14 centimeters squared. Okay? All right, so I had these fancy schmancy questions for perimeter, but I forgot to do them. But I'm just going to keep going with area. Then I'll go back to perimeter. Sorry that it does discombobulate. Hey, it's final exam, though. You got to be ready for anything in any order. So maybe I'm doing you a favor. Okay. All right, so for the drawing below, KN is 18 inches. What's KN? Good, everybody. That is a diameter. So what does that mean? The radius is 9 inches. Okay, so 9 inches, 9 inches. All right, so the area of the sector K to P to L. First thing you have to do is identify that from K to P to L. Okay, so this doesn't seem much different, but it requires that you read, you identify the parts that you're looking for, and you're able to make your own decisions about how you attack this question. So that is the area that I'm looking for. That's K to P to L of just that sector. So here we go. It's 87 degrees divided by 360 because that central angle identifies that that's what portion I'm dealing with. Times, this is area now, so area is pi r squared. Pi r squared. Okay, and offline, I'm going to go ahead and calculate that. Maybe. Yikes. Look at those ugly answers. So right before that, I think I can arrow up in this calculator. Absolutely. 87 divided by 360, press enter. I just think it's a good idea. Then 9 squared times the answer. 9 squared is 81, by the way. Press enter. And then that would actually be the exact answer because I never touched the pi button. And it does end. So that fraction is not rounded. It is 19.575. So 19... oh boy, that's how short. Okay, 0.575 pi, or do you see that ugly fraction? You know what, I don't think it's going to be that bad on the final. I just picked this drawing from somewhere, so don't get afraid of this answer. But I never touched the pi button, so this is the exact answer. And it's in inches, so this is inches squared. I should have squeezed an inches squared in there as well. And all you have to do is take this answer, enter, times pi. And then it might put it as a fraction. No, I wouldn't do that with 3.14. What am I talking about? All right, so this is 61.5 or 61.5 approximately inches squared. Okay, and then just to keep with the formulas, you know, some composite drawing, that's the wrong word, some area of shaded region where you have to make decisions as a student, you know, how do I attack these? And I'm probably going to take 2 of these. So this first one, this creepy looking guy looking over a fence at you or something. Looks like some eyeballs there and then whatever. But anyway, what is the area of this? All right. Well, first of all, this looks like a half circle, and that looks like a half circle. And they both have the same radius. What's a half plus a half? It would be a whole. So the clear part is a whole circle when you put these two together. Right? And then what's this a picture of right here? A bigger half circle. So the way I'm going to look at this is it's a half circle, big one. Really, you're going to say maybe minus 2 other half circles, but really those two halves together make a whole circle. So this is what you have to do when you have area of a shaded figure. You have to figure out what you got, maybe write down what it is, and then come up with your formulas after that. So this first thing is half of a circle. What is the radius of the big circle? That, which through simple math means it is 4. Right, so 4 squared pi would be the area of a whole big circle, but I only have half of that. All right, so really trying to hammer that down. Minus little half makes a whole. Hammering that down again. So let's deal with just this whole circle if I put these two together. So this would be 2, because the radius of this circle is 2, and that one is 2, so it's 2 squared pi. So this is how you'd find the area of the leftover shaded region, area of the half circle, minus the area of these two little halves.